Okay guys, so the steps to graph any function, these steps are still exactly the same, right? You figure out the parent function, you make a table for the parent, you want to identify a, h, and k and use those to transform your table, and then you plot your new dots. Now, this one should say example 3, and this one should say example 4. So just 3 to 4 for me, okay? So 3 to 4. In examples 3 to 4, graph each function, then find all defining characteristics. Now guys, I want to make these two equations different. So can you guys do me a favor and change this base instead of base 2? Can you guys change it to base half? Okay, so example 3, y equals negative log base half of x minus 4 plus 5. The first thing I want you guys to do is state the parent function, because your base in the original student is a half, so your parent function must have y equals log base half of x, just like that. Okay, so your original is y equals negative log base half of x minus 4 plus 5. So your parent function must have the same exact base. Now I want you to make a chart. Okay, you're gonna write the x and y values in there. And remember, if you don't want to memorize stuff, then all you gotta do is rewrite it as an exponential. This is half to the y equals x. So you're gonna go in and pick inputs, which the inputs now, they belong to the y. So negative 2, negative 1, 0, 1, and 2. Then plug it in. So we will have 1/2 to the negative 2, that will give us, that's kind of like 2 to the 2, so that's going to be 4, which I need a bit more space since I'm writing way too big here. Okay, so 1/2 to the negative 2 equals 2 to the 2 equals 4. Same thing with plugging in 1/2 to the negative 1, which is 2. 1/2 to the 0 is 1. 1/2 to the 1 power is a half. 1/2 to the 1/2 square is going to be a quarter. All right, so these are just the parents. So let's highlight them really quickly so you can see these are the points for the parent. Remember, each log equation, you have to look at the base for you to come up with the parent function. We can have so many different parent functions. So that's why you shouldn't be memorizing any of these, right? Try to understand them. Now, our equation is y equals negative log base half of x minus 4 plus 5. So your a is negative 1. Your h value is going to be 4. Your k value is 5. So we will go in and write 4, 5 for your h, k. Let's transform it. The a will go with the, sorry, that's a negative 1y. Negative 1 times y, your h will be added horizontally, and the k will now move up 5. So let's take all of these, let's get it from here, these ones, okay, and transform with those. So we should have 4 plus 4 is 8, 2 plus 4 is 6, 1 plus 4 is 5, 1/2 plus 4, that's 4.5, 1 quarter plus 4 is now 4.25. Then we will take, let's see, I guess this one, this color, all of those y's and transform those y's, okay? Negative 2 times negative 1 is 2. 2 plus 5 is going to be 7. Negative 1 times negative 1 is 1. 1 plus 5 is 6. 0 times negative 1 is 0. 0 plus 5 is 5. 1 times negative 1 is negative 1 plus 5 is 4. 2 times negative 1 is negative 2 plus 5 is 3. So we have enough dots here to go and plot. 8, go up 7. 2, 4, up, and then 7. 6 is now 6. 5 is 5. 4.5 is now 4, so you gotta go 4.5, 2, 4, 4.5 is now 4. Oh, can you guys fix this to 4 1/4 for me? Sorry, earlier I probably said 4 1/4, but somehow I wrote 4 1/2. So 4 1/4, go up 3. 4 1/4, go up 3. So can you guys see that we are not really touching? We're getting very, very close to x equals to 4. Well, look at that. X equals to 4. It's your vertical asymptote. So the vertical asymptote, y'all, is going to be the h value, whether you move right or left. Because remember, the parent function has a vertical asymptote at x equals to 0. So if you move 4 units to the right, so it should be now x equals to 4. Woo, woo. All right, so now try not to touch your asymptote. So I'm gonna make those dots super, super fat, okay? All right, now let's go and fill out the rest. X-intercept looks like you are going to cross over the x-axis. Can't eyeball that right now, so I'm just gonna hold on. I'm gonna do the algebraic work later. Let's fill out all the stuff that we don't have to do any work for. Y-intercept, we will not be touching the y-axis, so that's none. Your domain is going to be from 4 all the way to infinity. Your range is going to be all reals, aka from -infinity to +infinity. It is definitely increasing, it's 4 to infinity. That means it's decreasing, does not exist. It is 1 to 1. We don't have a horizontal. Horizontal asymptote go with the exponential in 5.4. We have a vertical asymptote at x equals to 4. We do have 3 transformations, guys. The negative is a vertical reflection. The 4, h equals 4, that's +4. So you can say right 4 units. And you have a k value that's also positive, so that's going to be up 5 units. Okay, so now the last component we have to calculate is going to be your x-axis, okay? X-axis is when y equals to 0. I'm using a different color here and try to squeeze that all in here. So 0 equals negative log base half of x minus 4 plus 5. First thing is we are going to move the 5 to the left. So that's going to be a -5 on the left side. Negative log base half of quantity x minus 4. Now, we want to isolate the log, just like you would isolate the exponential, just like you would isolate the radical. So we're going to multiply both sides by -1. So that's going to give us 5 equals log base half of x minus 4. Now, log is all by itself. The only thing left to do is write it as an exponential. So base is 1/2. Oops, base is 1/2. And I want you to raise it to the 5th power, just like that, equals to x minus 4. Now, 1/2 to the 5th, that's the same thing as saying 1 to the 5th and 2 to the 5th, right? Equals x minus 4. Well, 1 to the 5th is 1. 2 to the 5th is going to be 32. So that's going to be, I'm kind of running out of space, but I'm going to move up a little bit. So that's going to be 1 over 32 equals x minus 4. I want you to follow me over here to where I have a bit more space. So now that's 1 over 32 equals x minus 4. Now the next step is really just simply adding 4 to both sides. You can find a common denominator, but honestly, guys, it's a lot quicker if you can just see, okay, well, it's going to be 4 and 1 over 32. Now check this out. It should be super close, okay, to your vertical asymptote at 4, but because we can't touch the vertical asymptote at x equals to 4, so 1 and 4 and 1 over 32 is very, very close to 4, and that's why the x-axis is. Now let's fill that in. 4 and 1 over 32, comma 0. All right, so again, make sure you guys copy all of that down.